Okay, so now we're going to use the intermediate value theorem. It says show that the function has at least 2 real zeros between 1 and 4. Okay, so let me scroll this up. What we're going to do with this is we're going to look at integers. Now, our zeros don't have to be integers, okay, any real number, but we're going to use the integers kind of as stopping points to check, to see what's going on in between, okay? So let's go ahead and find f of 1. So we're going to evaluate the function at 1. And we're going to kind of make a chart here. Okay, so what do we get? 1 minus 5 plus 3 plus 6. I think we get 5. All right, so that's one of our points, one of our ordered pairs, 1, 5. All right, let's find f of 2. And our numbers aren't super large, so hopefully it won't get too bad. So 8 minus 20 plus 6 plus 6. That's going to turn out to be 0, isn't it? Well, that's interesting, because we're supposed to say, find that there are at least 2 real zeros between 1 and 4, and we just found one. So we found a 0. Yay, yay for us. Okay. Then we've got, well, f of 3. See what we get for that. 3 cubed minus 5 times 3 squared plus 3 times 3 plus 6. So 27 minus 45 plus 9 plus 6. What do we get when we put all that together? So 15, negative 30, getting a negative 3 there. Okay, and then let's do f of 4 and see what we get there. So you have 4 cubed minus 5 times 4 squared plus 3 times 4 plus 6. Now you might be thinking, wow, this is a lot of math, I don't want to do all this calculating and stuff. You could use a calculator. Maybe we've already found, maybe we've already shown that there are 2 real zeros. Before we do that calculation, let's look and see what we have. So if we were to think about it in terms of graphing, we know that there is a point, 1, 5. So 1, 2, 3, 4, 5. We know there's a point there. We know there's a point at 2, 0. And we know there's a point, I think, at 3, negative 3. Right? Oops, that was my point. There it is. And then we have a point here at 4 that we haven't figured out yet. Okay. Now, let's scroll back up. What do we know about end behavior? We know it's positive, and the leading term is positive, and it's, I shouldn't say that. The leading term has a positive coefficient, so leading coefficient is positive. The exponent is odd. So we know it's going to be going up this way, and then somewhere it's going to turn around because it's got to come down here. We know it's going to go on through, and then it's going to, well, we've only found 1 0 so far. So we don't really know that it's going back up yet, but we kind of suspect that because, right, so far we have not proved that there's 2 zeros. We've only got 1 so far. Now you might be saying, well, maybe there's 1 between 1 and 2. And maybe there is, but we don't know. So from what the information we have, we don't know. Okay, so let's go ahead and finish this calculation. So 4 cubed, let's see, maybe I should scroll it up a little bit so you can see it. 4 cubed is 64. And then we've got what? 5 times 16 plus 12 plus 6. So what's that? 70 and 82. If I add the positive ones up, and minus 80. So I'm going to get that to be a positive 2. Now that's where the intermediate value theorem is going to come in for us. We know then there's a point at 4, 2. right there. So no matter what that graph does, and I'm only allowed 2 turning points, so I've got 1, and now I know I have to turn here because I've got to hit that point there. So I don't know exactly what the graph looks like, but I do have some ordered pairs that show me kind of what's going on. I know I can't have any more turning points. So remember when we talked about, well, maybe something between 1 and 2? Can't happen because then that would be too many turning points, okay? So it could do some stuff. It just can't cross the x-axis. Okay, that would give us too many turning points. Okay, so I think we're good. I think we've shown from our points that we graphed that there has to be at least 2 real zeros between 1 and 4. Okay, so the graph shows it. You can think about the intermediate value theorem. You've got a -3 output here and a +2 output here, so it had to cross the x-axis between 3 and 4. And we already found 1, 0 when x was 2.